So, we are talking of diversity of usage. We said supposing I have got 100 hotel rooms, it is unlikely that all of them will be occupied all the time. So, only a part of it is occupied. Similarly, if you have, let us say, even in any space, any activity space, you have a number of outlet, let us say electrical sockets. So, all of them will be plugged in or all of them will be in use simultaneously, the chances are relatively low. So, there is a diversity of usage. Sometimes they may be all running full, I mean all might be used by everybody, while many other times there may be only one out of some n numbers that would be in use. So, this diversity of use is taken into account when we are trying to size the supply line, right. So, for example, as we saw earlier, we discussed earlier. So, this is called diversity in usage, we call it diversity in usage. So, supposing I have an electrical cable supplying to several points. Now, if there are n number of them, sizing of this one will not be on the basis of n. So, sizing is on the not on the basis of n, tends to make it uneconomical because of over design. So, you can, because all of them will not be, all n will not be in use simultaneously. So, you take only a factor out of this, and this is what we call as diversity, because all the time all n will not be used simultaneously. So, 100 hotel rooms, all rooms will not be occupied, sometime it may be, sometime much less. So, this diversity of usage we take into account. So, similarly, supposing I am supplying water. Now, water supply to all the rooms, if I take care of in the inlet pipe sizing leading to all the set of room in a given floor, that would be surely over designed and uneconomical. So, this is called diversity in usage, and in order to find out, I mean, we multiply by a factor, n is multiplied by a factor, right, and that factor of course, we determine statistically. So, that is what we are saying, diversity factor. If we have a hotel example wise with 100 beds, and we have hotel with 100 beds, let us say, and we want to provide centralized AC, if there are n equals to 50 some value, right, or similar cases, supposing there are 15 n number of 15 ampere outlets, we need to size the electric line supplying to that. We need, in this case, we need x ton of AC, since it is not very likely that all 100 rooms will be occupied. So, we multiply by a factor, and that is we call as diversity factor. So, this is diversity factor deals with this issue. If the design, in the design of services, we do not design for full load, but for a partial load depending on the satisfaction level. If you design for all 100, anytime anything happens, you are satisfying this. So, this is called satisfying 100% simultaneous demand, right, satisfying 100% simultaneous demand. But then we need not satisfy 100% simultaneous demand, we may satisfy some partial or a fraction of it, some percentage of it, and this percentage or fraction we express, we call it diversity factor. So, how do we determine this? How do we determine this? To do that, I got to know the probability of one outlet or one room being in use, right. Now, if I know one room in use, I can consider to be again a binomial situation. Probability of finding either a room in use or it is not in use. So, my success is it is in use, failure is it is not in use, right. So, the only two possibilities there. So, probability of a room, on an average a room is in use is important. Like for example, this is a similar case of a die, scenario of a die, right. So, in case of a die I had six outcomes possible, right. So, what is the probability in 10 trials, right, 10 trials I get success, that is, let us say success is the die outcome is 4, outcome of the die is 4, that I call is success, failure is anything else, right. So, in 10 trials or in n trials, how many times I will get, exactly how many times, probability of finding, let us say exactly out of 10 trials or n trials or whatever it is, exactly 4 or 5, 6 number of times 4 will come, or 1 number of time 4 will come. So, that is basically case of binomial distribution, right. Okay. So, similarly, but then for that probability of finding 4, in case of die we know it is 1 by 6, because 4 is one of those 6 outcomes, but in case of services outlet we do not know. So, we have to determine it, the probability of success, which is probability of finding any room in use, probability of finding any room in use. So, in order to do that, one can actually have past data. If you are trying to find it out, you should have past data. So, past data, for example, you went and you found out f1 time, let us say only one of those outlet is in use. You went and found that f2 time 2 outlets are in use, and f0 is no outlet in use. F0 is a number of times, you have actually done large number of experiment, let us say some 1000 times of something of that order, or if you have past data, from that you can generate. So, out of those 1000, out of those 1000 you found f0 is the number of times no outlet in use, no hotel room has been occupied, no outlet or no services is being used. I would rather call it no services is being used, no service is used. F1 only 1 in use. So, you went and found that F1 times only 1 in use, F2 time only 2 in use. So, if you sum up F0 plus F1 etc., sigma Fi, if I call it F0, I mean F0 Fi F1 plus F2, which is sigma Fi, that is equals to actually 1000 or whatever the value is, whatever the value is. So, this I can plot it in form of a histogram, this I can plot it in form of a histogram, right. So, you can plot it in a form of a histogram. So, in case of 100 hotel rooms, possibly it will look something like this, some 0 to 10 number of room being in use. Well, I never found that case. So, F0, f this value for 5, so 5 into 0, 15 into let us say 1. So, 10 to 20 number of rooms in use, I can even make them, because there are 100 of them, I can divide it into class intervals, that is what in statistics we do. So, we divide them into class interval, take the class representative value, which is the midpoint 10 to 20. So, 10 to 20 is 15. So, 15 into 1 plus 25 into 2 or so on so forth. So, therefore, I can find out sigma Fi into xi value, where xi is the class value, class representative value, class representative value. If it is not 100, it is much less, I need not use the class. If it is not 100, let us say it is 15 outlets or something like this, or 10 outlets. In that case, 10 outlet, in that case I need not take the class value, will be 1, 2, 3 itself. So, this divided by sigma Fi. So, this is frequency of observation, this divided by sigma Fi will give me the mean value. Mean value is class value multiplied by the corresponding frequency, sum it up, divided by total number of observations, right, or its first moment actually, as we call it, right. That is, you find out the, so this is what it is. So, mean number of mean number of bedrooms or hotel rooms in use, I can find out in this manner. So, this is the simple algebra part of it. Mean number of outlet in use will be given by x bar, let me call it, will be Fi xi divided by sigma Fi if I have done n trials, right. So, that is what it is. So, that is x bar. Now, I had actually 100 rooms. Out of this I find out that x bar number of rooms are, on an average I find x bar number of rooms are in use. So, probability of finding a room or probability of finding a success is simply x bar divided by 100, or in the not 100, I mean x bar divided by 100 in this case. I think I am calling it capital N. It should be capital N, not this small n, it should be capital N. One of them should be, so it should be x bar should be or x bar I have found out, probability is x bar divided by capital N, where capital N in this case was 100, right, because I had 100 rooms. Out of this I find x bar number of room is in use on an average, mean x bar number of room in use, right. So, that is what I can write algebraically. This is not correct, this should be capital N, where capital N in this case is equals to, capital N in this case was equals to 100, capital N was equals to 100 in this particular case. So, that is mean number of room in use. N is a small number of observations. So, I would have taken 1000 observations, out of which I found out, from that I found out the mean number of room in use. Sometime I went and I found 0 to 10, there are none, never it was less than 10, 10 to 20, the some number, like in my observation I found certain number of times, which I call as F1. If it is discrete 12 outlets where you are doing the experiment, so maybe you have found 0 time, no one is in use, you have found 0 time, maybe 1 in use, also you found that it is not. So, it will be 1 multiplied by 0, 2 multiplied by, let us say you have found 2 rooms, 2 outlets are in use, maybe sometime you have found out. So, correspondingly that the frequency. So, relative frequency multiplied by the random variable value of the value divided by sum of the frequencies, that will give you the mean value, and probability of finding one outlet in use is given by this mean obtained divided by number of outlets used in experiment, right. So, that is what you do. Now, this is a situation, this is the probability of success then. That means, probability of finding one room in use, any one room in use, right. So, if you have 100 rooms, any one room in use is probability is this, it is equal for all of them, it is equal, and probability of finding that room is not in use is 1 minus this p, 1 minus p. So, I now want to find out probability of 0 room being used out of some another, so my data I might have used from past data, where I might have had n might have been 100, but now I have a hotel in which I have 80 rooms, let us say, not 100, and I want to find out how many rooms I should consider to find out the diversity factor. For it could be different for air conditioning ducts, it could be different for water supply, it could be different for cold water supply, hot water supply, and so on. So, it could be different for different things. So, this probability has to be known to us, right. So, now this n might be equals to, let us say, n dash or some m, let us say it is m. So, now I have, instead of I want to design for a new hotel which will have 100, instead of 100 rooms it will have 80 rooms, which is m, right. So, out of m I want to find out the probability of, out of m, what is the probability of only 0 room in use, probability of finding 1 or less rooms are in use, probability of finding 2 or less number of rooms are in use, and 3, or now this probability will increase. So, if I want to the probability of finding m or less number of rooms are in use is 100%, because m is the total number of rooms. So, if I supply for all m rooms, I will satisfy all the time, come what it may be, but I will be oversizing. I will be doing oversizing. So, what I do, instead of m, I possibly use lesser number, some factor multiplied by m in my design, right. Now, this probability I have already found out from past data, the way that I have given the example. So, now I want to find out for m cases. Now, for this should be capital N.
Capital N and N are same.
No, they are not same, they are different.
They are both the number of rooms.
No, this is number of observations.
Capital N.
Small n. Capital N is the 100 number of rooms that I said. You can use interchange notation whatever you want to use. So, I used this, I used here, I have used, I am saying n outlets where the experiment was done, where data is available to me. So, this n is the 100 outlets, 100 bedrooms if it was. So, small n is the number of observations. In my statement it was 1000. So, n is the n is the number of room in my experimentation, total number of room used. Now, I am interested in finding out of m rooms or m outlets, how many I should be catering such that it is, because if I provide for all m, the supply line for all m, as I said, like I have got something like this is a supply line, let us say water supply line or air conditioning duct, and now this will be supplying to 1, 0, I mean 1, 2, 3 etc. up to m, right. Now, this sizing will not be on the basis of all m, it will be m multiplied by some factor which I am calling a diversity factor, right, multiplied by some m. Now, I want to find out, now information that is available to me is P, right. So, if I supply for all of them, I satisfy 100% demand. Out of, if I supply for m minus, if I cater, this sizing is done on the basis of m minus 1, then my diversity factor is m minus 1 divided by m. Similarly, m minus 2 divided by m, diversity factor is the 2, which means that if it is more than m minus 2, I will fail, I will not be able to supply. So, either I say that okay, you do not get SE in this room, the next already m minus 2 as people have occupied, if the next one comes, you get a non SE room, which is actually has got implication on cost, because it will have implication in cost and also your reputation, etc., etc. So, you have to, management has to decide what should be the value of diversity factor, but on the basis of what? What is the probability of failure, overall failure? Because if you provide m, you will satisfy 100% simultaneous demand. If you provide m minus 1, you will satisfy possibly this much percentage of simultaneous demand, some percentage, not this much, some percentage of simultaneous demand. We want to find out how much is this percentage. Now, this is a situation of same binomial distribution. I probability of finding a room in use, one room in any room in use and not in use, right. So, 1 minus that would be there. Now, I want to find out the probability out of m room, what is the probability of exactly 2 room in use, 1 room in use, 0 room in use, and if I sum all of them up, then it will be the probability of 2 or less number of room in use, right. Is it all right? I can find out the probability of out of m some x number of room in use, x minus 1 number of room in use up to 0, or I will do the mathematical exercise, algebraic exercise for all of them, then go on summing up the probability of finding 0 room in use, probability of 1 room in use, probability of 2 room in use, probability of 3 etc. room in use, and if I sum up all this probability, that will give me the probability of x room or less number of room in use. That means that much of simultaneous demand, and if I sum it up, go up to m, then it will be 100, because the possibilities are either 0 room in use, 1 room in use, 2 room in use, and all m are in use. So, sum total of all those probabilities will be 100. So, I just got to decide that what is the simultaneous demand I would like to satisfy. If I say I want to satisfy 95% of the simultaneous demand, then sum of this probability, and it will be up to, let us say, some y number of outlets which will correspond to 95%. Then I provide size this for y number of them, or in other words, I find out my diversity factor, which will be y divided by m, y divided by m. Let us look at this further. So, probability of m room in use will be given by probability of m exactly 0 room in use will be p to the power 0, because probability of finding 0 room in use, then all m room are not in use. So, it is a joint probability of 0 room being in use and m room being not in use. So, 1 minus p to the power m minus 0, and this 0 room can be any one of these m rooms. So, I can select them in MC 0 ways. So, that is why this is a binomial distribution case which earlier also discussed. So, this is the probability of finding 0 room in use. Probability of finding 1 room in use is similarly MC 1, because I can choose that room, maybe the first room or the last room if they are all equal rooms. P to the power 1, probability of finding 1 room in use and exactly 1 room in use and m minus 1 room in not in use, and this I can choose in this manner. Now, if I sum these two up, then I will find probability of finding 1 or less number of room in use. Similarly, I can do for 2 and 3 and 4 etc., and I sum them up, and if I sum all of them up to the last room, then I will get equals to 1. I will get, so dot 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 etc., I will get equals to 1. If I sum all of them up, I will get equals to 1, right. So, what I do is I find out, sum it up to this, then sum it up to this, progressively I go on finding out sum. When the sum becomes 0.95 for some value of x, p3, p4, up for px, let us say it is 0.95, then if I provide sizing I do for x number of them, then I will satisfy my simultaneous demand 95% of the time. And depending upon this p value, which is usually small, then you will find that in case of 100 rooms, you will satisfy 30 rooms, possibly you will satisfy 90% of the demand, or if you satisfy 70% of them, 95% of the demand. So, your diversity factor is 0.7 or 70%. So, similar is the case in electrical. There you sometimes they use thumb rule, but the idea is behind this. So, if you have data, then it is very easy to actually use it for a given occupancy, given society also, given locations, maybe hotel rooms, it would depend upon like it is seasonal and those kind of things. So, if you have data, then you can find out, maybe you take the peak season data and do the sizing. So, in peak season also your all rooms will rarely all rooms will be full, only sometime all rooms are likely to be full. So, this is called diversity in usage, right, this is called diversity in usage. So, if we want 100% satisfaction, we must provide all sum total equals to 1 up to m equals to 1. So, P0 sum of P0 plus P1 plus P2 P3 P4 Pm, that is equals to 1. The sum of all this equals to 1, but if we can take 10% risk, because the cost increases enormous, because 10% risk if you take, you will find that it becomes possibly 80% of the or 70% of the simultaneous demand you satisfy, risk you are taking is only 10%. So, that is the idea. So, you take sum total of all this equals to 0.9 you take. So, value is dot dot up to x, px is equals to 0.9. So, then x is the number of them. So, for example, if you take p equals to 0.2 and I have m equals to 10. So, p0 will be 10 C0 1 to the power 0 1 minus 0.8, because 0.2 is the p which you have found out from past data, probability of finding 1 room in use. No, 1 to the power, this is it should be this is correct, this is 0.2 to the power 0 and 1.2 to the power 10, that is what it should be. Like 10 C1 is 0.2 to the power 1. So, if you calculate this out, 10 C1 into 0.2 to the power 1 into 0.8 to the power 9, and this value comes out to be 0.268. Next value comes out to be 0.301. So, if you take and take just up to this, if you sum up to P0, P1, P2, 40% of the demand gets satisfied, because this is 0.268, this value whatever you can calculate out, C1 is 0.268 and P2 also I am adding. So, it is no much more than that, 0.3, 0.2 etc., etc. Yeah, 0.5 plus something more. This value is no, this is up to point, I think this is not correct. I mean, you can just calculate. The point that I am trying to show is that even 2 out of 10 if you select, you might satisfy more than 50% of the demand, 50-60%. So, you need not use all of them, and that is the idea, that is the idea, that is the idea, right. You can check this calculation, correct it, there is no problem. So, for 40% satisfaction, then I need to just take one of them, one may not satisfy, 2 might satisfy, because 1 will be less than 0.4, 2 will be more than 0.4. So, if I decide that I will satisfy, just as an example, small calculation I have taken. So, P1 plus P2 is greater than 0.4, actually it is greater than 0.4, therefore, I have to satisfy for 2, it is more than 4, 3.3, 0.2 etc., something whatever it is you can calculate out. So, this is what we use in sizing. Once we have seen earlier, we have seen that how do you find out capacity storage, and this is the network sizing. First thing we do is I should do the sizing for how many, that I should find out. Then of course, then the mechanics, physics, whatever it is, it comes into picture, right. So, that is the use in diversity in usage. Now, once I have done that, actually, once I have done that, now next is obviously the basic laws will apply now, right, because we have seen that supposing I want to do sizing for water pipelines, right, water network, water pipeline network I want to size. So, then the laws of water supply will be applied, and there we have seen that it is somewhat different. In fact, it is not linear. The driving force is basically head difference delta H in case of water, right, delta H or pressure difference, whatever you call it, and Q is related to delta H not in a linear manner, or P, delta P is not in linear manner, right. So, here there will be, it is a non-linear, while in electricity of course voltage and current they are related linearly, because V equals to IR. So, respective law will now apply, but then we have two types of variables which we have already discussed. Then one we call as across variable, which is the potential driving force, and another is the flow variable. And we said that at any junction sum total of inflow must be equals to sum total of outflow. And also we have said that in case of any loop, total across variable, sum total of all across variable will be equals to 0, So, that is how we do it. So, we will this is how we look at the diversity, and then diversity is used to find out the sizing basically, and that is what it is.